Today in Crazed Performance Repair, we're going to be talking about this LT-based engine here. This is a 5.3 L83. I have the oil pump sitting out of it. I've already gone through the cylinder heads, all that fun stuff. I'm in the process of putting it together, actually. But this is a prime opportunity for me to take an oil pump apart, inspect it, and show you guys what these oil pumps are all about, what's different about these versus the older generation, and why these pumps are going to be prone to more failure in the future. And I say more because, well, the other ones just didn't fail. I mean, the only way you could damage the old style pumps was literally if you sent sand through them. I mean, they were so damn robust, it was almost impossible for them to fail. They could have a relief valve catch problem, but aside from that, they really never ever failed. They were just so solid of a pump. These ones are a little different story. So, let's get right into it. We're going to go over to the pump and take a look at the differences between this and the other engine. So I have some parts laying all over the place here. It's just because I'm in the process of assembling. These are all the taken off parts, balancer. There's an alternator sitting behind here you can't see, some bracketing, some lifters, a couple of bad rockers, things like that. Just ignore those. Got all kinds of things everywhere, right? Alright, so we have the oil pump, oil pan, and the timing cover sitting up here for a reason, because this is essentially the real difference between this generation of engine, the LT-based engine, and the previous generation, the LS-based engine. The real differences are basically right here. That's pretty much it. I mean, there's a couple real minor things in the engine itself. For example, there is a oil squirter that squirts up at a follower for the roller of the high-pressure oil pump at the bottom of the block, or at the bottom of the valley area, I guess you would say. It's not the bottom of the block, but there's like a little deal that bolts up to an oil galley that has a hooked around little thing that squirts up at the roller there. So that's one difference. Also, the valley lifter oil manifold, that's the AFM system portion of these engines, is a much different design, and then there's an oil port. Instead of in the back of the motor, it's in the front of the motor now. So they kind of moved a couple things around a little bit, but essentially it still looks like it feeds the same way. I'll have to dig into that a little later. If it is different, I'll definitely bring a video up on it because it's important on how it functions. The previous ones, which is what it looks like this does the same thing of, I'm assuming it's the same. This is an assumption. This is the only assumption I'm going to make. The rest of it's going to be real fact. Looks like it sucks the oil from the sump into the pump, right through the bottom of the pump here. This would be technically right here. And then there is port here for an outlet, and that goes out to the block, straight back to the oil filter, into the filter, out the filter, and then into the engine, which is exactly what the previous generation did. So, as long as that's true and still the same, that's still the same. That's the part I have not verified as far as the block goes itself. I'm sure it's the same, though. If it is, and I find something, I'll throw a diagram or something on the screen, whatever. I'm pretty confident in that, though. I just want to make sure I'm not concrete because I don't want you going, hey, he's wrong, you know. So there's that. That's basically it. The sump is now part of the pan. I mean, you can unbolt it and take it out, but it's kind of like built into the pan. Here's a gasket that seals up against the pump when you bolt the pan on. The pan now is RTV'd into place. Previously, it had a gasket, and then you have little rubber rings for the oil sump and the two pressure spots for the oil filter area right here. Then, of course, you also have this little secondary pan here. This is like where the oil slosh control is. There's a little bit of baffling at the bottom of the pan here. And then this is where the oil sump actually sits down into. You also have your filter right here. So, that's the oil pan. It's a bit different than the previous generation. We also have the timing cover here because there is one major difference between this and the previous generation. And there's a lot of similarities, though. So we have this connector down here that was in the same spot. Goes up, brings some wires up. Goes to the VVT solenoid here. Some models previously did have this and some did not. I think all the new ones have this now. I'm pretty sure. And of course, you got a wire connected to that. And then there's another wire here. This is the one that's different. This is the part that changes things. This is a pass-through connector going through the timing cover. It goes clean through, has a wire here, and this wire connects to the oil pump. So this oil pump has a solenoid valve on it. And this solenoid valve right here is for a variable geometry oil pump. That's why this pump looks so much different than the previous generation of pump. Actually, I'll go grab a previous generation so I can give you a side-by-side comparison. I have one sitting here. Now, this one is from the LS-based engine. This is actually, it wasn't an LS2/LS3. Originally an LS2, the guy converted it to an LS3. Long story short, it's basically an LS3 oil pump, but aftermarket performance pump. Now, I haven't pulled the rag off of here because I want you guys to see the difference in this thing and how crazy it is. And just look at it alone without taking the cover off, the size comparison. This is a much bigger pump. So, we're going to pull this off. And side by side, look at the difference in those things. I mean, the bolt pattern is much wider on this one, so they changed that on the block. The oil sump is located on the other side on this one versus this one on this side, so they moved the sump location. This part is going to be the same, I believe. Yeah, I'm pretty sure that's identical. So that doesn't change. But the sheer size of this new pump design versus the old one is just insane how much bigger this new pump style is. Crazy. So this one here has a weird two-piece gear thing in here, and it's basically impossible to destroy. Like I said, you have to send sand through it to wreck the thing. I mean, it's very, very robust. Relief valve sits right here, and then where does it blow it through? Oh, that's right, it returns it. So it's a return. This is the pressure feed to the block, and it returns it back in through this little area right here when it has to relieve pressure. So very, very simple design. Spring, full mechanical. Nothing really can go wrong with these things. I love these pumps. They're awesome. Very, very reliable. However, these ones, I haven't had a failure with them yet, so I'm not going to condemn them totally. There is that solenoid that is a cool feature, but once we get this thing apart, you guys will also probably be wondering, is that really a reliable design? Because there's a lot of moving parts in this thing. So, let's zip it apart here, and then get you guys an overhead shot and visual as to what we're dealing with. I have not pulled one of these apart yet, so we're doing this together. I was actually going to do a live stream on this, but because my phone died that I previously would live stream on, and this is a backup unit, I did not want to just go live streaming right away. There is a pin, so this is like a pin or something, and it feels like it's holding it. I don't want to overly stress things yet. Oh, there we go. Yeah, it was just, okay, so there was like an oil suction seal because of the machine surfaces. So that shouldn't be a big deal. So I gotta pull that up. I want to make sure I don't pull that bottom plate because there's going to be some vanes in here that I'm expecting to try and make a hell of a mess for me. So I'm just going to take and set this aside. I'm going to flip it fast so I don't lose the screw hole areas. And then I'm going to be inspecting this plate later for damage. And I don't know if we're going to fully disassemble this thing. It is a wild pump. Let's get you guys an overhead view. I may just inspect it as is and put it back together. We'll see here. See how brave I feel. So, we have multiple vane plates here. We have a very, very large spring. This solenoid is going to be using oil pressure. It's not going to actually physically move the pump itself. It's going to use oil pressure to pressurize against the spring to change the geometry of this unit as far as how it builds pressure up. So I think, you know what I'm going to do is I'm going to pull the spring out of here. I think. I'm very hesitant on this. I don't want to create one hell of a ruckus. I'm afraid I'm going to, though, because science, I really want to take it apart. So, the things I do for you guys on YouTube, I would not do this if it wasn't for a YouTube video. I'll be straight with you guys. I would not mess with this thing right now. It's fine. Leave it alone. Don't piss with it. You know what I mean? Let's see if I can pull just the spring out. I just want to show you guys. This is probably the stupidest part of doing this. It's pulling that spring out because it might have a crap load of tension. Oh! Ouch! Ouch, 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 ouch. That is a tight spring. Okay. We have the spring out of there. Got lots of oil everywhere. So now we can see how the thing moves and see the geometry changing. Okay, so we're going to put a bolt in here. So I got the pin over here that's holding it on one side. I want to hold it on another side here, just so it doesn't move around while I'm trying to play with the geometry of the thing. Okay, so if we look at this guy, it moves back and forth like this, right? So we have the inlet comes in here. Okay, so the inlet is going to this side right here. This is going to be rotating this way, of course. I gotta try and keep that centered somehow. Wait, is that going to be rotating that way? No, it's going to be rotating this way. Oh! Okay, so I gotta think about that. So if it's rotating like this, it's going to be pulling the oil around here, throwing it into this area. There's a chamber. I can see a chamber right here, and that goes to this side. Yeah, so that goes to there. Yeah, that hurt my finger. That thing smacked my finger pretty good. So it's going to be pushing the oil around through here into there, and if it's in that position, that direction, so the spring is fully compressed. Now I see two sweepers right here, two seals. There's a little seal right here and a little seal right here. And then I see, I should get a pic for you guys, a port right here and a port right here. And those appear to go down towards where this solenoid is. Now the question is one a feed in and one a feed out? Or how does it work? Oh, there's another port right here. Ah, that's from the pressure side. So I'm willing to bet you it pressurizes this, adds a little bit of mechanical leverage to it, which is why this spring has to be so heavy because it's already going to push this direction. I'm going to give it a push once. Yep. So it's going to be pushing that direction at all times, but when they put pressure in here, it's also going to go right here and fill this cavity. You would think it would push that way, but because of the angle of this, I don't think it can. Yeah, it's not going to give it any leverage that direction, but this direction, absolutely. So, when the solenoid opens, it's going to fill this cavity with oil pressure and push this additionally that direction, compressing this spring and changing the geometry of this unit. So, we're going to take and I'm going to hold this center as I can. I'm going to move. I got to do this with you guys being able to see. So I'm centered. I'm going to move it this way. You can see how that chamber completely changes its dimension and size. So it opens it up over here and closes it over here. So doing that, it's going to allow more oil flow in and squeeze it into a tighter spot over here, like that. Then when we move it this way, it's going to make it very slender over here and very wide over here, which means it's going to compress it and kind of push some back into there because that chamber goes all the way to here for that inlet side of the chamber. And it's only going to let a little bit through. So when it activates that solenoid, basically, is when it drops the oil pressure. That's interesting. At least that's what it looks like at first glance. I'm going to drain this out a little bit. Hopefully not create a mess. Besides the oil, I don't want parts everywhere. See if I can just put it on a rag and then discard the rag. Okay, I don't see anything underneath there. I wanted to do that just in case there was something underneath there. Well, you guys didn't come here for the pump not coming apart, I suppose. So, I guess I'll take it apart. What the hell? No guts, no glory, right? Let's see what this component list consists of. Okay, so we have a ring here. This is a ring that keeps those vanes in the right orientation. We are going to have the vanes themselves. I can take all those guys out. You can see they have a little wear spot on them. A couple of wear spots on them. Those are going to be all the same size, I'm positive of, because they rotate around here. So I shouldn't have to worry about those. And I'm noticing the wear spot is closer to the inside. I don't know. Oh, I suppose because they're slinging out, or they're sitting out. I don't know if that's any relevance to the variable, what position it sits in. I don't think so, because it's always going to be moving as it goes around. Okay, I'll pull this guy out. We have another one of those centering rings, so this is the part that's going to make it tricky. I'm going to have to put this in first, then start sliding the vanes, and just like I took it apart, reverse of what I took it apart with, and use the vanes to try and center this ring where it needs to be. That's going to be tricky. So we got that. Let's go ahead and pull this guy out of here. This is the actual variable motion portion of it, whatever you want to call the damn thing, I don't know. Then I can show you guys that seal system. You see these little wipers right here? Ooh, oh, they're two pieces. Oh boy. Oh, ho, ho, ho. That is interesting. Look at that. We got a dual piece. So one's a narrow little black piece. It's much more narrow than the channel it's in. And then this green wiper that sits on top of it. So that black piece almost looks like an O-ring. That might be acting like a spring to push against this little, maybe that's a harder seal. Yeah, that's a harder, almost a plasticky seal. So that O-ring must act as a spring. This is getting interesting. I'm glad this is on video, because when I go to put this back together, I might need this video. Alright, so there's that. Suppose I can pull this bolt out. You can take this guy off now, and look, I can just move it over, pick it up, flip it over, set it aside, and then we got this plate here. Now you can see the actual channel system I was talking about, how it's really wide here, and that's where that variable changes. It makes it really narrow where it's still going to this, so some of that excess pressure is just going to keep circulating inside this little area. Rather than build pressure, it's just going to stir it around. Big stir stick, right? And only let so much of it through. And it appears that's when it's in just the spring pushing against it mode. Now, I wonder if because it has this port that's always feeding the pressure from this side, I believe, let's verify that first. I'll wipe some of this off, because I want to inspect it too while I'm in here. I'm paying attention to everything. I'm looking for any unusual wear or anything, and I don't see anything alarming yet. I mean, there's a little bit of scuffing here, but nothing bad. Okay, let's go see if these bolts are all the same length. Sure looks like they are. Yep. So we don't have to worry about them. Now, this guy comes off. Come on. There we go. So we'll flip this guy over. Oh, we have this, it's collecting like this nasty debris right there. That's interesting. Okay, so here's that port still. I don't know where that port is getting its pressure from, though. Oh! I know where that goes. What the... Okay, that's a big difference from the previous engine. I gotta show you guys that. Hang on. That is cool. Okay, so this is a cool design. I'll give them that. It is a very cool design. Do I have the old tensioner? I thought I had it, but I might have threw it in the scrap pile. Oh, wait, there it is. Okay, here it is. So, these engines here, this tensioner plays a part in this oil pump, believe it or not. Very interesting. That explains why you can't do the timing chain without having the pump completely off of the vehicle, besides the fact that you can't get the chain around it. Wow. Okay. We're going to back up a little bit. Once upon a time, I did a full delete, and, this previous pump design, being much smaller like it is, okay? I was able to pull this pump off. Well, it sits this way. I could take the bolt out for here. Without pulling the oil pan, I was able to pull the pump off. This one, this whole bottom section of the pump sits below the oil pump or oil pan. You cannot remove this pump unless you remove the oil pan. It is completely impossible. Not a chance in hell. And thus, you can't remove the sprocket for the chain. But even if you couldn't remove the sprocket for the chain, if you could at least move the pump around enough to get the chain around the pump and over the pump and out, you can change the chain, but you can't even do that on these. There's just not enough room because of the pan. So, well, and actually, this is probably almost too big for the chain. I mean, that's about the chain size. This thing's huge. So, this port that I was questioning where it's coming from, this tensioner has this hole here, and I was wondering, what the hell is that hole for? When I was doing this job, I didn't think twice besides, that's weird, that hole is a rubber, I wonder if that's a sound dampener. Wait, it looks like I got one in a hole in the block? That's just bizarre. Whatever. Kind of threw it in the back of my head and didn't think twice about it. Now, I realize why that hole is there. There is a port right here that goes up to that, and this guy sits right like that. Check that out. How crazy is that? So it's getting oil pressure from the block of the engine. Why is this so revolutionary or cool or whatever you want to call it? Why am I so astonished by this? What it is doing, essentially, is by having the oil pressure feed into this guy. I'm going to go ahead and kind of pre-assemble it here. I'm not going to do the vanes and stuff, but you guys will get the idea. I better move these O-rings, or whatever these things are. Don't want to lose them. Alright, so we'll just kind of set this in place. So by having that pressure right here behind this section, and it's applying that pressure like this, pushing against that spring, when it pushes the spring down like this, it decreases the amount of flow going into here. So what this is essentially going to do is make this relief spring almost irrelevant. This is very, very cool. What's happening is if the engine isn't meeting enough oil pressure for this spring will automatically build up the oil pressure. So if it's got tons and tons of oil pressure, say you're at 40 psi and at idle they only want 20, that 40 psi is going to be enough to overcome this spring doing that, changing the geometry of this thing automatically, mechanically. That means that it's going to drop the pressure and make it so that it will have less pressure in here, thus kind of leveling out, finding an equilibrium to make that 20 psi of desired oil pressure based off this spring. I don't know if it's 20 psi, I'm just throwing a random number out there. But based off of this spring, it's going to use this to make the base oil pressure off of. Then, by using this solenoid, if they want more or less pressure / volume, they can activate this solenoid. It would make it less, actually. So having this spring just by itself with this is maximum pressure and volume. By using the solenoid, you could further pressurize this, making it go even further this direction, dropping the pressure more to increase fuel economy for, say, sitting at idle at a stop sign. The less pressure you have to build, the less mechanical force is needed to build said pressure, the less fuel you're going to consume. Wow, consume. That was weird. So, this is a very, very cool design. I'm actually kind of impressed with this design. I like it. I like it a lot as far as its practicality. What I do not like, though, is its reliability. I am a little worried that these vanes, these tiny little metal plates, are going to be prone to failure when they're not filtered beforehand. The only thing that filters them at all is the little screen on the oil sump. It would be nice if they could do something similar to this, maybe with like this style pump that feeds it a very low amount of pressure, say only 10 psi or something, but it's filtered before it gets to this style of pump, like a two-stage pump system, and then have this variable geometry for the high pressure side. So this would be a low pressure, high volume, and this would be a high pressure, high volume capable, but it'd be variable geometry depending on its needs. And then you wouldn't need the relief valve that is also built into here to spray the excess pressure out this way. Now, this relief valve, the only purpose I see in this relief valve on this one is during shifting. And the reason for that would be you have that, say you're revving it out, you're balls to the walls, right? You're bringing your RPM up, it's coming up to 5,000, 6,000 RPM, and it shifts, and it instantly drops 1,000 RPM. That instant drop, all that pressure has to go somewhere in the oil system. So if it has a relief valve, it can go doot and just burp it out for that split second of that shift, and then it's no longer used anymore. That's the only reason this would be very useful. Otherwise, you're going to have a little spike of pressure right when you shift. Not that it's a big deal. I mean, they've been doing it for years with basic systems, although they have a relief valve, so maybe the relief valve took care of that. I don't know. I've never really seen it on the data log, but that's the only reason I could imagine having something like that. So, this is pretty cool, though. Made in Canada. Well, that's interesting. Normally I see made in Mexico on GM stuff. Weird. Alright. Well, I'm going to clean this thing up and get it put back together. There is no torque specs on these bolts that I could find in any of my data. So, if you're taking one of these apart on your own and you want to just inspect your own pump, they do have procedures for inspecting the pump. They give a, what each part is, what you need to look for, things like that. But they don't actually give you any specifications as to what torque is for the various things. So my suggestion would be take the thread size, the material it's going into. You can look this up on Google or DuckDuckGo or whatever, and you can look up the thread that you have, the pitch of the thread. This is going to be a 6x125, I believe, and find out the torque for that style of thread in said material. These are getting torqued into aluminum, so they're going to have a torque spec per aluminum. And then if you get really complicated graph, it'll actually go off of the contact thread length as well, but I don't think I'm going to have to go that fancy. This is going to be 89 foot-pounds most likely. Or not foot-pounds. Oh my god, that would break the crap out of it. 89 inch-pounds! Don't listen to me with 89 foot-pounds. Holy crap. 89 inch-pounds. So, there's that. Now, one last thing I'm going to do, though, before I put this thing together, is clean out those relief valves, or relief valves. That relief valve and the solenoid. So, pulling that apart is really simple. There is a little clip here. It just has to be pulled up on. Make sure you hold on to it. It's probably like a Jesus clip here. Hold on to it, he says. It'll be fun, he says. There it goes, he says. Jesus. Oh, I found it. Whew, got lucky. There it is. Alright. Good thing for a clean shop. Alright, so here is the solenoid. There's a screen on the end of it. You're going to want to inspect that. I don't see anything else going on in there. Oil in there. Pretty basic. There's not much else to it. And then this guy is going to be an Allen head. I'm going to have to pull that apart separate. Actually, that's kind of cool. I don't even have to pull it apart really to inspect it. I'm going to pressurize it, I think. Oh, I don't have to. I can push right on it. Cool. This is actually kind of neat. Check this out. There is a check ball. You can see the check ball through these holes. I don't know if you guys can see it on camera. But right here, there's a check ball. I can see the check ball right there. I can take this guy and just make sure it moves. Oh, come on. It's pretty stiff spring. All I want it to do is move just a little bit. Just a little bit. I can't quite push on it. I wonder if I got something else. I feel like this is going to scratch the aluminum. That's why I'm not pushing very hard. Oh, here we go. This will work perfect. Push rod. It's got a nice ball end on it. Oh, yeah. Yeah, pushes nicely. You got good spring tension. I think that's going to be fine. I'll just go ahead and clean everything off, put it all back together, and this guy's oil pump will be all good to go again. I don't know why there's so much sludge in that little cavity. There's no holes to it whatsoever. Weird. Alright. Hopefully you like this somewhat raw video. I'll cut out the dead spots, but aside from the dead spots, it's going to be pretty much a raw video. If you guys like this little disassembly process, you should have worn gloves. Be sure to like, share, subscribe. Leave a comment below. What did you think of this weird pump? You think it's going to be reliable long term? I don't know. After seeing the parts and how it's built and what its purpose is, it might be okay. I mean, if it starved oil for any amount of time, I think it would suffer really quickly and get damaged really fast in comparison to the other style. But it looks like it's built okay. It might be pretty dang reliable. So I don't expect to see too many failures from the pump. Now, the solenoid, I could see that failing. I could definitely see this failing. It's an electronic component with a little coil of copper wiring soaked in motor oil. And who knows what other chemical somebody adds. You add Marvel Mystery Oil or sea foam or something. It might deteriorate the coating on the coil in here. I don't know. That's something for debate. I would be very curious to find out if something can break down, what kind of chemical would break down the coating on an electrical coil. Just my little initial thought on that. Besides that, I mean, I really don't think this pump will be that big of a problem. There's a lot of parts, a lot of movement, which makes me want to think it's going to be unreliable. But I don't know. It seems built pretty good. So, and I like the design. I like the thought. All right, leave your comments below. Let me know. I'm gonna get back to work and get this thing put back together because I got a vehicle to get running. I gotta get this thing off to the alignment rack. I got lots of work to do. I'll bring a live stream though soon. Sometime soon, I will try and get a live stream, and I really want to get you guys more live stream. I've just been too busy. If you want more information, go to my website. I have all kinds of crap on there. I even have a personal vlog thing going on there where I show you shop updates, but that's only for subscribers, premium members, etc. I'm not going to get into that spiel. I have that on my other videos. Enough with that. I'll see you guys on the next one. Thanks for watching.